Thing is, humans will also do some mistakes sometimes. Every human will have chances that he will commit some mistakes. So indirectly, I can say they are good, but thing because of this nature, we can say we are less reliable. But when compared to the machines, you see the machines, they will take the less time, and they don't have a no chance for errors. Okay, errors means not I'm talking coding errors. I'm taking a decision making level. Okay, right. As long as your logic is correct, your program never make any mistake because everything is instructional. Have you ever seen a washing machine works malfunction? I mean, we never because everything is already verified, and so whatever is coded is embedded inside that particular chip, and it will work accordingly. There is no chance. At 100% accuracy, I can say there is no chance for errors if your program is as long as your program is correct. Right. So just now we have seen these are some fantastic capabilities of the digital machine. Now, so definitely there are some interesting because we can make use of this. Why don't we make use of this digital machine? That is how. So they are saying that there is no chance for errors, and I think everybody knows that the computers are perfect. I mean, I'm not taking if a program is correct, if you are written the logic is correct without any mistakes, and there is no chance that whatever is input is given, it will give the correct output. Okay, so input and output. So whatever is input, the output is always correct according to the particular logic on which written. Okay, so definitely they have good processing capability because the main heart, the processor of your the digital machines are nowadays are coming with so much of speed. They can process the information very fastly than human. And of course, if they are processed and they are very accurate because humans maybe commit some mistakes, but your machine never does the mistake. If you see, for the particular solving some task, some problem, I can say, or problems, some task, your human beings are taking or task means it can be analyzing the things, and it can be memorizing task, whatever say. So for the task, human beings are taking more times, and I'm saying that your missions are taking less time, and there is a chance for errors. There is no chance for errors. In these two perspectives, we can prefer the digital machines instead of the human being. But the question is how to make your machine to learn or memorize or to analyze the things. How to make your machine, your digital machine, I am saying today, digital machine to learn or memorize some things. Understood? Suppose if I'm bringing this capability, if this fantastic capability of your human brain, who is memorizing, and and if this capability is given to a machine, if this capability is given to this digital machine, what is the capability? Learning capability. Then, in that case, can I replace the human being with the digital machine for any task? I'm not specifically saying NLP. Yes.
So kindly repeat your question.
Yes. Suppose if I given this fantastic capable learning capability to your digital machine, your computer in the sense. So can I replace your human being? Can we replace the human being?
Yes, sir.
Yes.
We
So
can.
that is what we are doing now. We are soon, we are gradually we are uh, try to replace the human beings in different scenarios. Nowadays, you are seeing these autonomous vehicles. There's driverless cars. The earlier the necessity of the human being, now it's no longer necessary. Human being, the computer, the car means inside there is a computer. It function. It learns the things on the spot, and it will drive you and take you to the safe place, the safest route. It will drive on its own. How it is happening. Yeah, so that is the advantage. If you see, uh, if the best part of your human brain is given to your machine, that's what means the learning capability is given to the machine. So definitely we can replace the digital human being with a digital machine. Right. In that case, what will happen? There are so many problems which, of course, human being will address all sort of problems, but there are certain problems which you can process more effectively than human brains. Effectively, in the sense, the more faster and more accurate by digital computers. So, similarly for NLP, also come to the NLP part later. The question is how to provide this learning capability to your machine, guys. How do you provide to digital machine? Just compare the human learning process with this. If I'm making if I'm making your digital machine to learn, so this process is called artificial learning or the machine learning. Yes, but how? Please think of it. Just try to compare with the natural language. So this is how you have to develop the research skills. Okay.
So using memory, in memory we keep whatever is learned previously, and then we compare.
Hmm.
Then by comparison, we know whether it is similar with the previous experience or not.
Okay. You want to make so there is some database you want to make one-to-one comparison sort of thing like that you are saying. That is not
Yeah.
memorization. Okay, that's of course that's memorization, but it's not learning. So learning means I will tell simple. Okay, what's the difference in memorization and all? Okay, debug memorization. When I'm saying 2 plus 5 is equal to 7, okay, it's memorization. So when I give 2 and 5, you will say it's 7. Suppose if I given 5 plus 7, you don't know because you know that only 2 plus 5 in your brain, only 2 plus 5 is equal to 7 is written. But if I given 5 plus 2 is equal to what? So when I know,
Yeah. So process should be known.
yes. So when I know that 2 and 5, when I am looking at the plus, so you have to add, and that is some is output. This is how you should learn. Okay. So when I'm saying whatever I'm giving, you are saying 7 7 7. It's a memorization. You're batti antar. I mean, you are something. Your mama keep on mug up or something, right? So for people who is mugging up, if I have given some tricky question, what they does, they will whatever they are learned, they memorize in their room. They will put it on the paper. That's called memorization. But what is the learning? The learning means when I'm saying say the 2, when I'm using plus and 5, you have to add it. It's a 7. So when I know this process, I mean when I know logic inside this, then I can. So that's called learning. So you have to learn like that. Okay. Understood the memorization and the learning?
Yes, sir.
Yes. The question is, how can we provide such kind of capability to your human brain? That you're not human brain, your digital mission. So let us talk about our digital mission. So now our topic is now this is a digital mission. So when I'm saying the digital mission, it will have memory, right? Everybody, do you agree? Your computer will have memory, right? It will have a
Yes, sir.
microprocessor and some input IO devices, some IO. This is a digital mission I'm talking. Just give me 2 minutes. Let me have the water. Then we will come to. It's very interesting. Uh, Guys, sorry for the inconvenience. See, this everybody knows that your digital machine will have the memorization, memory will have, and the microprocessor and the input. Okay, so these devices we know, and these every digital computer will have. Suppose I can give some input. Okay, okay, and if this input, suppose I am saying it is 2 plus 5 is equal to 7 or whatever you are saying. So when I'm giving input, it will in memory we can memorize, right? That's the rule. So as somebody just now said that suppose I want to learn, so I will give 2 plus 5 is equal to 7, 5 plus 2 is equal to 7, 1 plus 2 is equal to 3. So all the stuff will go and store in our memory, it will dump here. That is called memorization. When I am saying that 2 plus 5 is equal to 7, 5 plus 2 is equal to 7, and 1 plus 2 is equal to 3, I have something I have given 2, 3, 5, and 5, 3, 7, 8, 1, 2, 3. Then I will ask 3, comma 4, how much? I given 2, comma 2, comma 3, comma 5, 5, comma 3, 8, 1, comma 2, comma 3, 3 and 4. We know that it is 7 because what I'm the last term I'm getting by summing up these two. 2 plus 3 is equal to 5, 5 plus 3 is equal to 1 plus 2 is equal to 3 plus 4 is equal to 7. Because why I have written like because I am not specifying the exact functionality. What is happening between these two should learn. Like you might have seen missing terms, find the missing term, find the next coming word. Because how do you identify? If I'm saying the 2, 3, something like 2, 4, 6, 8, next term, what is this? Because when you understand the logic behind this, then you can identify it. So this is called a learning. To make your machine, this digital machine, memorization is easy, but to make it learn, it's called machine learning, is there is a role of this processor. Why? Because what I'm trying to do, how I'm making to my machine to learn is I will try to write in a program. So this program will be stored here Yes. So I will try to write one computer program, and this program will be stored in your memory, and it will be processed by your microprocessor. Yes, but what is the there in this program? The logic, the learning logic. Understood? If you don't want to learn, there is no role of the microprocessor. Of course, to run the computer microprocessor, but as a, in the the active role of this microprocessor is not required, because just keep in take input and store in memory and fetch it from some specific location when it's required. That's called memorization, remembering. So when I want to when I make my machine to learn, how I can accomplish? By writing a one computer program. That computer program will consist of the actual logic, and this will be stored in memory, and it will be processed. The logic will be processed by your microprocessor, and thing is, this program is also required some kind of inputs. It will require these inputs. Do you agree? When I'm giving this inputs 2 comma 3 5 5 3, then your logic will learn, and this how this logic will learn when it is executed by your microprocessor. Then the logic will be learned. Right. This is how the supervised learning will happen in the digital computers. Any doubts so far? I mean, guys.
Yeah, I think participants, if you have any queries, you can. Otherwise, sir will go on with the session. Sir, you can continue, sir. At the
Okay.
end of the session, they may ask.
Okay. Okay. Just because I'm breaking
Yep.
the sessions multiple. Okay. No.
Okay, sir.
Yes. So I'm summing up. So if I'm putting all together, so there is a, I can say, algo or your logic or computer program, and this computer program will have some inputs and it will have some output. Of course, this logic will be run by your the computer in the large scale. This is run by on your computer microprocessor, no problem. It won't run in the air, right? So this inputs is called data set. So if there is a data set and this is given to you an algo, and you will get your required output. So if I summing and put it in crisp way, so this is how a typical machine learning, how the machine learning happens at the mission, digital mission. You must write this. This is your task. Who has to written? The you have to develop your own logic. Okay. So I hope it is clear for you how this is a very basic knowledge is required. So this is how the learning happens. Nowadays, everybody, if you ask what is machine learning, everyone says this so and so algorithm. It's not actually like that. So you have to understand how the human learning occurs and how the learning happens and what is the role of the microprocessor and memory and input to make it happen. Right? So now this is supervised learning. Why it is supervised learning? Because you are providing the inputs already. 2 comma 3 is equal to 5. To understand the logic behind 2 and 3, you already given some ground truth. That's why it is called supervised. Now, thing is, what are the supervisor? So when I'm saying sir, this is supervised
I
algorithm.
have a question.
Yes, yes.
Sir, in case of general programming, or you may say procedural programming or object-oriented programming also, when we give input to a function, it gives the output, and we have given the procedure to it. So, what is the difference between this machine learning and this super procedure learning?
Okay, okay, very good. Yes. Suppose I want to write some program, add x comma y, x plus y is equal to z, print of percentage d, the z. Isn't it? This is what you are talking. And if I given 2, 3, right?
Yes, sir.
Very good. 2 had 3 have given, what is the output you will get for the same program? If I given 2 comma 3, you will give output, you will get 5. If I give 3 comma 2, you will get 5. So 1 comma 2, you will get 3. You will see what is the functionality of this. The logic behind here is you already mentioned explicitly. Plus, you already mentioned the logic that if you give 2 and 3, you are getting 5. Right. Suppose something like,
Yes.
okay, I have given, suppose you don't know what is written here, okay? You don't know. So what is here, written here? Just think there's a block box. There is a block blocks. So I have given and it's given 2 and 3. And it's, this block box is giving 5. Okay. So you are making a note. So when I give 2 and 3, it is saying 5. Wow. So when I give 10 and 20, it is giving 30. Oh, when I give 10 and 20, but you don't know what is written inside this. And you are given 30 40. So 30 40 you are given, it is output is given 70. We don't know. It has given 10 comma 2, it is given 12. You don't know. Now I am doing the reverse engineer. If you see, so what you did earlier, you are given 2 and 3, you got 5. 3 comma 2, 5. Suppose given this, so given outputs of this is outputs, okay? Guess what is the functionality behind this block box? Understanding? Just I given
So,
this.
this functionality will be generated by machine.
Yes, this functionality will be generated by your machine, nothing but your program. So this I will written one program here, okay? In computer program I will written. So what this computer program does, it will observe, yes, it is giving 2 and 3 like human being, 2 comma 3 given is 5. 10 and 20 given 30. 30 2 and 2. Then the output it will give is this, the according to the inputs and output relationship, these are inputs and outputs relationship, it will identify that the relation. So this is input x and this is input y, is output z, it will give the z is equal to x plus y. So it
So,
will identify.
basically, what I understood is in case of procedural programming, input is there, process is there, and you will get the output. In
Yes,
case of machine learning, input and output is there, and a program will be there which will try to understand the relation between that input and output and will
exactly,
generate
yes,
some
that is the logic, the
procedure,
relationship between, yes,
etc.
because this is inputs given, this is outputs is given, and you have to identify the logic. So this program will identify this logic, the logic is this one, that is equal to x plus y.
Okay.
The logic will learn, that is a, so suppose how you know that it's a 2 when I'm adding 2 3 5, because you are a human being, you know. But of course
Yes, sir.
that is the beauty and fantastic capability of human brain. That's why we are able to do the same thing. I want to give it to our machine. How the? Because just now I mentioned, if you want to give, so you must have some data. This data will have inputs and outputs. It will try to identify this the relation between these two with the help of this algo. Your output is the logic. Your logic, like Z is equal to X.
So why don't we have same algo for all the input and output?
Why don't we have?
Same algo for all in. input and output? Why we have different algo for different input and output?
Why there are so many algorithms?
Yeah.
Obviously, there is a performance issue.
Okay.
So because one model is good for, suppose if you are seeing in the market there are so many scooters are there, why don't we have single model? It's not like that, because somebody is good at pickup, somebody may good at mileage, somebody may good at what you call comfort. So according to your requirements, okay, it depends. The requirement change, your vehicle will change. Like that, if the requirement change, so what is your priority? So accordingly, we have to choose the classifier. Of course, this will, that's I'm talking very extreme level. So when you have a good knowledge of each and every algorithm and all, and under which scenario you have to use it. Suppose if you take 2 into 3. Suppose your microprocessor does not support
Okay, sir.
this,
Thank you, sir.
uh, doesn't support your star operator, or what you will do 2 plus 2 plus 2. So you have to do. So like that, so according to your requirement and your like that. So that's why, so there is a one theorem is called no free lunch. Okay, so what it is saying that there is no global algorithm to solve all sort of problems. So when so maybe this kind of data is suitable for some kind of algorithm, some kind of programmer. So depending on the data set, we have to choose it. Okay, somebody may not, if you take decisions, say some classifiers won't work on categorical data. So what you have to do? So you have to do you have to convert into, do some kind of pre-processing steps and convert, or you have to do some kind of discretization steps, or so like that you have to do it. Okay, so obviously there are multiple algorithms are there, and you have to pick up the one which is giving good one. So there is no global algorithm which solves all the kind of problems, hence there is no classification algorithm. This kind of a supervised model, there's no single supervised model to sort all the problems. Okay, so it depends on your the problem statement, or your kind of the data you are giving as input, and the complexity of the problem, and all they will come into the picture. Okay, so so if there is no one algorithm to solve all the problems, what is the need of studying this? The one who has invented, he might have get some Nobel laureate and everybody started using it. It's not like that. Okay, it's applicable for this. Understood? What's the difference between the compute this? Okay, it's
Yes, sir.
very good.
Thank you, sir.
Yeah, it's very good question, because people will get confused. This algo means this algo is different and this algo is different. Okay, of course this is also an algo. So this algorithm is saying that if I given 2 and 3, it is giving 5 output. This algorithm is implementing the addition. But what is this algo? So this algo, this program is nothing but your algorithm. This is also an kind of algorithm. So this algorithm is be made such a way that it will identify what is the functionality inside this block box. Of course, it's again algorithm which is run by a microprocessor and all this stuff. But the logic we are using inside this law is, this is not the same. The logic we will use is some different, because the input here is I've given some input and output relationships, and how can we analyze this input and output relationships? At the last I will get more accurate uh, output. Okay, how accurately I am predicting my outputs. Okay, so in the just now the topic came, so there are so many algorithm machine learning supervised models are there. So so many supervised models are there. Like if I'm saying, you can say Navy based classifier. It's supervised models are also called the classifiers or classification algorithms. Okay, there is a, so so let me list down some of the classifiers, well known classifiers. Okay, Navy base classifier. So the other one is a KNN classifier. So let me talk about for some. Let me spend on some couple of minutes on each and every classification algorithm, so that I'm not going in detail about each and every classifier. Just I'm spending some important points of this classification algorithm, how we can make use of it and all this stuff. Right. If I'm saying this Navy based algorithm, it works on the principle of the Bayes theorem. It's nothing but probability theory. So probability theory, it works and everybody knows that how to find the condition, especially I'm saying conditional probability. It works on the probability theory, specifically is a conditional probability by using chain rule and all the stuff. If you see, when a moment I am saying it's a probability, so definitely it is not suitable for the categorical data. Okay, 1 second. 1 second, just so there is a categorical data. So what is the categorical data? So I will use my age. Age, if I am saying 27 years or 30 years, it's a numeric data. If I am saying age is the middle age, young age, old age, something like that. So this is categorical, okay? Categorical, okay? So when I'm the moment when I'm want to use a conditional probability and all the stuff, so definitely it is not suitable for the what you call categorical numeric categorical data. Which ones? And there is a chance that zero probability. Yes, there is a sometimes that, so there is a chance of the probability may zero. So in that case, so you can, I don't suggest this naive based classification. I think by this time you all know what it's a kind of supervised algorithm. So every supervised algorithm will have this algorithm will change. That's it. Input is same. Your output will be your logic. The logic inside this data. Okay, in output. This is called your data set. I'm exploring different kind of algorithms like Navy base and KN and all this stuff. I'm discussing that. Okay, what are different kind of algorithm? For every algorithm, it's common. Remaining parts are common. Okay, right. Now it's a categorical data and all. Now it's okay. Now let's talk about nearest neighbor. So what is the nearest neighbor? So if I'm saying a 2D plot, when I'm exploring in a 2D plot, so there are some data points. Right, what I'm trying to do that I already know what is the ground truth information of this. Suppose I'm saying this is a positive class, 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 this is a positive, and we already know that its class level is negative, 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 negative. Okay, now this is a class level ground truth information. Okay, now I'm saying that I will do what is the k. So I want to identify came to the new sample. This is my new sample. So what is the class label of it? That's what your classification does. Okay. So what is the class label? Like plus or minus, whether it's a what is the class where say it's plus, what is the plus or minus? Which one it is? We have to assign plus symbol or minus symbol. So what I'm trying to do, it is based on the distance based classifier. So I will try to use the Euclidean distance. I will take some Euclidean distance and the k. I will try to find out the what is the k nearest neighbors. What I have to try to do, I will find out the distance from all this. You already know how to find the Euclidean distances. You will find the distances to all the samples. Then you will find the distances and sort in descending order. So this ascending order. Sort in ascending order or increasing order of distances. Once you find the distance and sort in the increasing order of distances, so the k nearest neighbor, the first k points are the nearest neighbors, which are very close to a given point, because from that point we have found all distances. So then we will try to identify what is the class level of the class level of this, the class level of this, class level of this, and in this I am saying this is a place. Okay, So what is the majority of the class? In this case, if I can identify the class label of this k nearest neighbors and apply the majority voting. So what is the majority of the samples belongs to which class? Obviously, the positive class, hence the class label of this new sample will be the positive. There are some certain issues how to choose this k and all, that's altogether different. Okay, but so this is ideally suitable for the both categorical and numerical data. And the only thing is computational cost, because you have to find the distances for each and every SAM. Very expensive, and sort it. And sorting is not an easy task. Okay, and it's logarithmic n log n, best cases n log n. There is no linear sort. Okay, best of my knowledge. And this is not what is very expensive. Right. This is one sort of approach how we can find the supervised model, how we can make use of the supervised models for a given task. When I'm saying about ANN, artificial, it's very, very important, artificial neural network based classifier. So these ANNs are taken inspiration in your human brain structure. So what is this human brain structure consist of? It consists of set of neurons. There are neurons in your human brains, and these neurons will be interconnected. Okay, suppose I'm something like this. I'm interconnected. I'm not like this. This every neuron, and these neurons are interconnected. That is the structure of your human brain, right? If you take a human brain, if you observe closely in microscope, then you can see that there are so many billions of the neurons are there. So these neurons will get interconnected, and this whole network, the bunch of network, will play the key role in the memorizing the things. Yes, so taking the inspiration of this human brain, they started this mimicking the. They want to mimic the human brain, and then people started. The one who has attempted in this direction is McCullough Mikula and Pitts. There are two scientists. So why don't we develop a mathematical model for the human neuron? Okay, human brain neuron. Okay, so they started this mathematical modeling human brain neuron, and they started the creating such a complex network. Okay, so the reason for why I'm discussing the ANNs is one of ANNs also used for the supervised task classification. Right. See, so there are, again I'm talking about there are different type of ANNs. So if there is a set of neurons, these neurons are organized in the layered structure. This is layer 1, layer 2, and the layer 3. And every layer will have certain number of neurons. There is interconnection between one layer of neurons to other layer of neurons. And if the connections are only in one direction, and the neuron in the other layer will have the inputs from its previous, all the neurons in the previous layer neuron, then this type of architecture is called feed forward architecture. Suppose there is some kind of loop or some kind of the connection to the back of its a neuron. Okay, suppose here this output, this neuron will have interconnection, will have again and connection to the previous layer neuron. If this is the case, so this kind of connection is called a feedback neurons, feedback architecture. In the feed forward new architectures, we can study so many architectures are developed on in the principle, and so the connections are in only in one direction from the left to right only. Okay, so this type of networks, if you see, there is a multi-layer feed forward neural network, multi-layer perceptron neural network, and if I'm saying about radial basis function RBFN, and the probability neural network, and so what is the other sort of and RBFN, PNN, or TDN, time delay network, and so there are so many neural. When I'm talking about the feedback, maybe even CNNs also you're talking about convolutional neural network, which is mostly used in deep learning for image processing area application. And if you take feedback, you will have RNN, okay, and Boltzmann machine, okay, Boltzmann machine and all this other they have. So recurrent neural network, Boltzmann machine, this kind of feedback neural networks, okay. So the idea behind this neural network is to try to mimic the human brain. They try to mimic the brain, okay. We already discussed the capability of the human brain, all this stuff, okay, I'm not coming again. So this is how the ANNs have been developed for the uh, classification purpose. They have organized these neurons in a layered architecture and they have made interconnection. And this whole bunch of network will try to mimic the human brain, means like it memorize the things. And as long as you will, so you will have some inputs and you will get the output is the logic, and behind the input your data set. This is called data set. Right. If you see, and there is other category of algorithm. I'm not discussing what is it. If you are talking about limitations, here the some supervised model is. So, and of course, I forgot to mention there are some weights W1, W2, W3, W4, and so W1, W2. So this same the weights of this layer and the weights of this layer. If I'm putting in some column wise, so you can call it as a weight matrix. Capital W, it's a weight matrix. This is the weights between input layer 1 and 2. So weights between input layer 2 and 3 between weights between 1 and 2 is 2 to 3, like this, something like that. If I stagnate, if I'm stacking together one by one column one at adjacent columns, then it's form a weight matrix. So the question is, how do you find these weights? Initially they will arrange the random, but how do you find these weights? Gradually. Okay, because there are some learning algorithms are there. By these learning algorithms will adjust these weights according to the learning the principle. Okay, I am not discussing that. The question, the tricky part is, so these weights will get adjusted over the number of iterations, and at some point of time your network will get stagnated, means there is no update in the weights, right? We can say, then when I'm saying that there is no update in my weights, means there is a no scope for the learning process, the learning is over. So in that case, what will happen is you can say that indirectly the knowledge is represented or stored in the form of weights. So these weights are invisible. I mean, we can by looking. So there's a weight matrix 0.1, 0. By looking at this, we cannot interpret anything. So then people started using some kind of rule-based classification algorithm. So what I'm trying to do, there is a data set. There are certain inputs, then one output. Now our idea is to identify what is the relation between input and output. Okay. So usually output is a class label. Okay. The ground truth information. So what we are trying to do, we are trying to split this. There is some measure, and based on this we will split, and again we will split. So again we will split. Again something like this. Until there is some measure which is 0. That is 0. When I am making it, this measure is 0, I can say that there is no partition. Yes. So when you take the whole data set and partition recursively until there is take some specific measure and make until this particular measure is 0. So as long as you don't have this measure is 0, you cannot stop your algorithm. You can continue it. So this sort of algorithm, if you see, this is the invert. This is a kind of if I am saying that the data set is represented one kind of node, it look like this. Okay. This is the old data set, this is a sub data set, this sub like that. So if this is something like a tree, and that's why it is called why it is called decision tree, means this tree is used to identify the class label. What is the class label? If I given 10, 2, it's a 12. To identify this 12, okay, this is kind of a decision, kind of prediction, it's a decision. So it is identifying the like plus or minus symbols, a kind of decision. This is allowing this with the help of this tree you are making effective decision. That's why it is called a decision tree. That's why it is called a decision tree. Decision tree. And there are so many measures are there. And if I am talking about particular measure, there is a famous one is the Gini measure, and other one is the entropy. The other one is some cross what you call error rate or something. And another one is ratio, gain ratio. Okay, gain ratio is based on entropy. Okay. If I'm saying the entropy, everybody knows Shannon entropy. You know that pi into log minus pi into log p summation over I is equal to 1 to n. If there are n clauses, there will be the pi into log pi, and it's minus m. Like that, we will find the Shannon entropy. So when entropy is zero, then you can stop your algorithm. Hence, once your entropy is zero, then so this will become a leaf node. So try to remember when the entropy is zero means the clause label of all these is same. In that case, only entropy will be zero. The clause label of all the samples in the sub data set is same, then only the entropy is zero. It means that one second. Okay. This presentation. Yes. So when the entropy is zero, in that case, the all the class label of this is same. So that's why it is called the leaf nodes. So leaf nodes will usually will have same class label. Means that indirectly we can say that this will give some sort of, suppose the class label of all these is a positive, means we can say it is it will represent the positive class. And if the class label of all this is a negative class, something like this. So when I'm traversing from top to bottom, so it will goes to the particular leaf node from top to bottom. So for which leaf node it will goes, and according to we can make the decision, right? So this is how we can make use of the decision tree. It's kind of a tree data structure. So we will recursively partition your data set till you get a pure partition. This is called a partitions. Right. So these pure partitions will help us making the decision. That's why it is called a decision tree. So these are some of the supervised models which I listed here. All these are supervised models. Models are used for any kind of problem solving. But if you want to use, you can use it for solving the different kind of the problems. But thing is, if you want to apply the supervised models, the kind of data you are giving as input, the data you are giving should be have the inputs and outputs. Like this output is called ground truth. If the data is of the ground truth sort of data, then you can definitely apply supervised models. If it is not what you call if the data class label is absent, then we can use unsupervised learning models. And this all there are different kind of unsupervised models also there in the literature. So okay, with this I've given how we started our discussion with the natural learning and machine learning, and we try to the map the how the digital computer process the things, and what's the difference between the procedure and the algorithm in typical programming language, the algorithm in the machine learning, both are different. Okay, don't get confused. And then we have seen at the last, we have seen a different kind of natural supervised models. Now, so let us discuss something about the NLP. And if the time permits, I will try to integrate how we can make use supervised model for the different kind of problems in the NLP, right? And this content I have taken from the IIT Bombay. Um, so let us talk something about what you call basic stuff in NLP. So if we natural language means, so we will come. So in the the early stages, in the 50s or 70s, we used to talk with the machines. I want to communicate with. I want to talk with the machines. So you must have some language, machine language we have invented. So these are different. Okay, we invented machine language. With the help of this machine language, we used to instruct your machine. You do this, and all this stuff. Like maybe this program, maybe COBOL. I think this in the 80s we have invented. Before there is a punch cards we used to, in the logic we used to write. Okay, like then. But nowadays, how we are communicating with the machine today? You are telling your machine, you are instructing something in the form of not in high level language. You are instructing your machine that something like that. I need a dinner reservation for Valentine's Day. What you does, it will talk with your system and will let you know that in which restaurant it is available. So that's the big case. How sophisticatedly we developed our machines so that they are able to understand your natural language, because usually they don't understand our natural language, how the humans will communicate. And but usually we will prefer to communicate in the communication with the machines with the help of programming language. Maybe in the soon we don't know that, of course, to develop this understanding this natural language by your machine, again you in turn you will use programming language. And but you see how one level extra means just on top of a machine programming language, you are putting one layer extra, and in that layer you are talking with your machine. Hey machine, I need a one reservation, please can you find one dinner table for Valentine's Day, something like that. So they will interact with the system, and they will say the how we are interacting with your system. That's very nice, right? Now, so when I'm saying, when I'm instructing when I'm talking with the natural language to the my machine, so what are the things? So what are the things uh, will have key role? Okay, the speech recognition. This is one of the area we have to focus when you want to talk with the machine. They have to identify your speech and in which language you are speaking, and your pronunciation and all the things they have to. It's a very big area. And language analysis. Okay, so what type of language he is talking, or whatever language he is typing. So your machine has to understand and reply in the same language. The dialogue processing, of course, it will involve both speech and language. Sometimes you may select your chat box, chatbot, and information retrieval. Of course, something I wanted to say, hey Google, please search the material related to the machine learning. You're instructing a machine, okay? You can retrieve information. Earlier we used to type, now we by the help of maybe in another TVC is also coming with the voice recognition. So there you can get the required information will be filtered out directly without typing anything. Okay, so text to speech, and nowadays I think most of the NPTEL lectures, the earlier text to speech and speech to text, we used to have a what you call the speech, whatever the suppose if you take the video recording of my class, and I want to convert entire thing into the speech or text. So there is a speech to text and text to speech converters are there. These also works on the principles of the again, of course, internally we'll use some sort of machine learning only, because first they have to understand what type of text it is and what is the distilled. Then of course, there is a without machine learning there is no NLP, but we have to integrate these two and to get different kind of application. So text to speech we can have so many, and speech to text there are so many applications are there and all this. And very early 2020, in the IBM has developed one chatbot, and it's called Watson, and which is competed against the world's best geopad risk companies. Okay, so that's a very big the time of 2011. It's one of the early inventions of the natural language. But with the Watson, we can interact with your system. You can develop your system by the making of this Watson platform. We can create in a very easily accessible user interface. I mean, user interface means by voice or by typing or some sort of easy communication. We can talk with your systems like that. How hey, hi Alexa, hi Google, something like that. Of course, the machine translation or the language translation, it is one of the functionality is provided by your Google, and it sort does. So here there is a role of again machine learning and NLP. So you have to understand what kind of language. For that, you have to know what is the linguistic phonetics and all this stuff. And you have to understand this language. Okay, once you identify the language, you have to convert into the target language. Okay, this is called machine translation. So to perform the required, but we have first, if I have written anything, so you have to understand clearly. Suppose what I have written something in Chinese, what does it mean? That I study material for the machine learning and deep learning. Okay, so if I'm putting all the application together, the natural language processing is a machine translation. So where the Google has playing key role nowadays, and there you can translate from one language to other language. Okay, I think nowadays you can type in the Telugu and Malayalam and in the chatbot and even in the WhatsApp also. Okay, the information retrieval just by the help of either text we already know, but there's why hey Google please play what you call Bimla Naik song. So now it will play, right? Now how the things are, how we are interacting with your TV. Earlier, maybe now the smart is how we are interacting, how we are instructing your TV. But the voice, it is understanding its voice and it is immediately translating into the text. Something like that. And the question answering, of course, it's a kind of dialogue systems and information extraction. So if there is a speech information is there and text information is there, and how can we extract the meaningful information from this unstructured data, speech and text, your documents and all these are unstructured data. How we can make this unstructured data for your effective what you call decision making process. Okay. Text summarization to summarize in a crisp words what is the overall, instead of going through overall content, if I'm putting developing an algorithm that will summarize the contents of entire book or entire paper, and also sentiment analysis, everybody know by looking at your feeds or your content, you have to identify whether it's a positive content or negative sentiment. Is a what is the overall opinion mining sort of thing, what is the overall opinion of that particular feed or the particular text, what is it? Because we will use some kind of by identifying some words and giving the what you call the score for these words, and accordingly we can that does this sentiment analysis. Okay. And these are some of the applications we can use this NLP in developing chatbots and text summarization and in sentiment analysis and information retrieval and the machine translation. Okay. So what are the core technologies that we can integrate with the NLP? Because NLP alone we cannot use it, and we have to, because definitely we require NLP when you want to deal with the natural language. You require NLP techniques, but alone technique will not solve your purpose most of the cases. And of course, in the machine translation. Suppose if you want to detect the language, in that case, the alone NLP is not required. But for the machine translation, we can you don't require this AI and ML techniques. So, what are the core technologies we have to focus when you want to use the NLP as a part of your application? Okay, so we can use it for language modeling techniques. We can use it. What are the different ways we can model the particular language models, and so understand the parts of speech and is syntaxes and also. Okay, so then synaptic parsing and name entity recognition, words and if there is an ambiguity, how to resolve it, and the semantic role labeling. And there are some core technology we have to focus as a part of your NLP. And so NLP lies at the intersection of the computational linguistics and the machine the learning. Okay, so it is uh, it has some concept from the computational linguistics that we will have inherited from the computation, some properties we have inherited from the machine learning to accomplish your task. Okay, so what is the level of the linguistic knowledge? Okay, so if you take any particular natural language, if you will have some kind of if you take a speech, if you take speech, what you call when you have a speech kind of data, it's both are unstructured, it's unstructured data. It will have some phonetics and all this stuff. And if you take text and orthography and morphology, texemes and syntax, you have to understand semantics, pragmatics, and all this stuff. Okay, so the pronunciation phonetics means the way you are pronounced. Somebody will pay the, somebody will pronounce the, Tyson, Tyson, Thiasin. Somebody, how do we are pronouncing this? Called phonetics. Will how we are pronouncing your sound. And the words, the language modeling is called. First, you will divide the words. Tokenization means you divide your words, and spell checking, spell correction. Suppose when you are typing the Google, it will do spell checker, right? It will also on the base of the NLP only. The tokenization is the process of dividing your entire sentence into what you call the words. The morphology is a morphology token. This is in a simple sentence. Okay, and so identifying the parts of speech and what are the correct part of speech and all this stuff. Okay, this all comes under the language modeling. Okay, so then we have to do syntactic parsing. So it's we have to check whether this is syntactically the correct according to the target language. In Telugu, it may be according to your what you call I don't know what it's called, grammar. What's a Telugu grammar? I don't know. I forgot. But if you talk about English grammar, grammatically we can verify it, and by parsing by tree and by parsing constructing some DAX type of structure, parsing tree we can call it. Okay, so by constructing the tree, and if it's according to the tree which is the parsing tree, then we can accept that sentence as a grammatically correct and all this. See, now the information, the way we are interacting with the system, our computer system has been changed drastically. So we have seen that we are communicating with our systems, our computers, with the help of language, and there the NLP will play a key role, and and that too we can make use of the supervised models. So when I say that I want to know, identify what is the sentiment analysis. Suppose if you're able to identify particular keywords and the presence of these keywords in a particular the text, and overall we can get what is the overall opinion of a particular tweet and all this stuff. So definitely there is we can make use of the supervised model for sentiment analysis and all the what you call applications of the NLP. And this NLP will play the key role. It will provide some flexibility, one layer top of your typical programming language. Usually will communicate with the programming language to your sister, your computer, but now this way with the help of this NLP, so you can have a flexibility to interact with your system, your computer, uh, one head. I mean, by naturally. If you are not comfortable with English, you can talk with your system, your TV with Telugu also. So that's the kind of flexibility we can get, and it's based on this we have n number of application nowadays we can see. And the best example you can see is your Google Assistant, which is installed in your system, in your TV or in your mobile phone. Okay, So with this, I'm stopping my session, and hope I've given very basic knowledge, the in depth of how uh, the machine learning will be used for the supervised model or the supervised, but I very lessly